All right, this video is the third in the AI chatbot series. So if you're not familiar with this app already, please check out the first video where I give a demo and explain what it can do. But just to orient you quickly for this video, this is an Office AI chatbot. It can answer any question about the Office, or any characters or events that occurred during the show. And in addition, courtesy of ElevenLabs and voice cloning, I have implemented the ability for the app to respond in Michael Scott's voice. So in this video, I really want to talk through the template repository that Vercel made available, which is what I use for this. And this template repository, which means that anybody can copy it to their own GitHub account and then clone it and modify it as needed, was a super handy starting point. It is very full featured, so if you're familiar with the UX or the UI around just OpenAI's chat-GPT chat models, then this will feel extremely familiar and even appear and look familiar. But in essence, what I wanted to talk through in this video are the changes that I needed to make in the Next.js app. And I thought an interesting way to do that might be to first look at a local Git diff. So I needed to Git diff the Vercel Labs AI chatbot repo, and then my own local copy of my Office Oracle repo, because due to the fact that I used a GitHub template repository, they don't actually share any history. And so essentially I just diff them as if they were completely separate repositories. And in essence, what you see here, I'm just going to quickly talk through everything at a high level, and then I'm going to go jump back to GitHub and we can kind of talk through the changes that I needed to make via pull requests and the commit tab. That might be easier to kind of grok them. But I'm going to go relatively quickly here. So on the left, this is the Vercel Labs AI chatbot template repository. You can see that I just essentially cleaned up it or removed the .env example when I turned that into a .env.local file, which I made certain not to check into version control because it contained secrets. If we continue to page along here, there's going to be differences in the actual Git config and some Git objects. We're not as concerned in that. The README comes very fully featured, and so I needed to rewrite it essentially. And so this is the initial README. Looks good. It's got a deploy your own button and some eye candy. And then in my case, I just wanted to talk through what the project is, show some images for it, and talk through what it can do. So I rewrote this README and added my own images, which kind of demonstrate the core functionality. So essentially you can ask any questions about the Office, and then you get a pretty accurate response. You can even ask for some kind of humorous tasks, such as draft a humorous email to my boss. I'm going to be late because I discovered YouTube, and you'll get back pretty much what you asked for. And so this was me just rewriting the README for my own purposes and explaining kind of what I was doing. So I very much needed the exact concept that was set forward in the Vercel Labs OpenAI or AI chatbot template. And in my case, I wanted to explore using langchain, Pinecone.io vector databases, and then the Vercel template itself. I used Stable Diffusion for these images for what it's worth, so that was pretty quick and easy to generate. And then I used ElevenLabs to do the voice cloning and text-to-speech. So this is me rewriting the README for my own purposes, basically. And then what are the other high-level changes that I needed to make? So before we look through it, the initial sort of implementation here that's provided by the Vercel Labs template is a generic chatbot, and it demonstrates how you can use the OpenAI API and get some responses. In my case, what you're starting to see on the changes on the right, I knew that I wanted to use langchain in order to serve as sort of the glue code wrapping the LLM, which is going to be OpenAI's ChatGPT 3.5 16K context window model, and my Pinecone vector database, which stores all the embeddings or the text. which form the corpus of knowledge that this AI chatbot is extended with, right? So this is essentially me just adding the ability for my existing Pinecone database to be set up and initialized via the API key and retrieved as a Pinecone data store, which I then later use in langchain as a vector database for recall. So in this case, this is all happening in the existing API route for chat. Probably could still do with a little bit of cleanup, but for the most part, it made sense to me to put the logic here. So initially, I'm creating a Pinecone client, and that uses my API key that is securely stored in Vercel as an environment variable or local as an environment variable. And then I actually create this reference handler to the index itself so that I can use that index, and in this case, set up a vector store. And this is coming from langchain's own wrapper for Pinecone. So at the end of this this block of code from line 56 to 59, then we've got a vector store that is suitable for passing into the rest of the objects in the langchain library. There's a simple prompt that I used, and there's a lot of good information on prompt engineering. I'm not going to get into it in this particular call or this particular video, but essentially what I found in my case for this project is when I was building out this prompt to be full of information, that was kind of a smell that my actual data quality was low, and I was trying to compensate by adding lots of logic and rules inside of the prompt to try and get the agent to do what I wanted. And you look back at the previous video in the series, it's about the Jupyter notebooks that I used to basically diagnose and fix and solve my data quality issues. And so once I did that, this prompt is now significantly smaller. It's a few lines than it was originally. I think I was writing like a paragraph of instructions, which was kind of a smell. But over here, we are setting up a larger context model. It's just the local variable name that I have for it. And you can see the model name passed in that I mentioned. And so in this case, there were there was generic functionality that existed in the Vercel template in the AI chatbot app, which made a lot of sense and worked well. It was essentially to do a streaming response as the model streams back answers, to write them in a streaming fashion to the UI so that the user understands that things are happening. And then also to use the KV store product for Vercel, which is backed by Redis, to do things like build up chat history for each individual user so that at a subsequent visit, users can access and see their own chat history, similar to the way that the OpenAI UI works right now. Okay, so here is the interesting piece for folks that are interested in langchain. So here is where in TypeScript, so langchain's currently supporting both Python and JavaScript and TypeScript. So in this case, I'm creating a chain, which is a conversational retrieval QA chain. The fact that it's prefixed with the word conversational means that it is intended for use via chat context, which is what we're doing, so that is appropriate. And then from LLM, I call this method and pass in both my larger context model and then the vector store as retriever. I do say return source documents. This is partly so that I can just console.log or console.dir, which is what I'm doing here, just dumping the messages to make sure that the response looks good. And that's what I do here. And then it's just easier to basically, when you're watching locally and testing this, to debug it. And I just slightly modified the way that the response is returned, so I saw that it was just a standard response, and so sort of, quite honestly, in the name of expediency, I just wrapped this new response, and I wrapped the result.txt, which is the answer that our chain, or the LLM plus vector DB, is going to give us, is just wrapped in a standard response and returned to the client. So that results in the text messages from the agent or from the AI bot getting written into the chat history window right in front of and alongside the user's own messages. So if you're not familiar already, LangChain is a very powerful library that is emerging as the sort of the standard way to write LLM applications, or applications that require LLMs. and or other sources of data, such as a vector store. So in this case, because it's such a common pattern to set up a vector store that has contextually relevant embeddings for whatever topic or swath of work that the AI bot is going to do. In this case, it's a vector store that I've created with the Jupyter notebooks that has the entire summary of every episode that happened in the Office series, so that the AI bot can respond as if it's somebody that has been there. And so you can ask it questions about the show and what happened and characters and episodes, and you'll get back relevant results. That's all instrumented in really a few lines of code thanks to the langchain library. And that's where you see the power of combining one variable here, which is a wrapper around OpenAI's chat-GPT 3.5. It could be other models if you want. And then the vector store that I created with Pinecone. So together in those two things combined means that when you pass in a question, which is really just this user query that in a very kind of rough way, I'm just popping the messages off to get the latest one that the user sent. This is pretty brittle and gross and should be refactored, but the point being, the message the user sending in is really just a query. That's what this question is, and so you call the chain awaiting the response, passing in the user's question, and this chain does everything you need, including roll up that prompt that we saw a little bit above, or is instructing it to respond as if it was Michael Scott. And so in just these few lines of code, you're getting that entire pipeline of functionality that's going to first turn the user's query into an embedding itself, so that it can be sent to the vector data store, and then semantically appropriate and relevant matches can be retrieved. And because we've set up the chain in this way, the vector store itself is consulted as a retriever by the LLM itself. So in that prompt, you'll notice we had this little context interpolated variable. And so these source documents that are getting returned from the vector database based off the embedded version of the user's query also get fed into the LLM at runtime when it's attempting to answer the question from the user. And so those two things together, the LLM itself, which has been trained and is pretty smart but doesn't have all the context we care about, the vector DB itself, which in milliseconds can return all of the context we care about based on the query, together form the actual final functionality that we see, which is, if I do say so myself, from using it, satisfactory in creating the illusion of somebody that knows the source material very well. And so that's exactly why I wanted to build this app too, is to just get hands-on experience building an application on an arbitrary corpus of content. In this case, it happened to be The Office. That was just something that I knew well in the background, and therefore would be easy for me to spot check for data quality issues, which I found pretty early on, given my first attempt in the way that I was approaching actually getting and storing the data. So yes, moving along here, I added in a utility class this sort of just this function that sets up both the Pinecone client and then attempts to get your environment, the API key and the environment that is needed from securely from an envars, and then does an init with the Pinecone SDK in order to return a client that can be used to query any index or data store later. Let's see. So moving on to here, now that we get into layout, this is some stuff that I was doing in order to get the sharing functionality. So if somebody pastes a link to the Vercel app or shares it, like if they go over here and grab this link and then paste it into a message in LinkedIn or a tweet on Twitter or a post on Facebook in order to share it with somebody, what is the image that actually gets rendered? Well, now that I've done that work, which I can show you in code here in a second, this is the image that they'll get. They'll get this at the special route that exists. OG stands for Open Graph, which is the standard for sharing images on social shares that way. There's this static image that I created, and I was able to style the text the exact way I wanted, as well as the image. And it's another one of the images that I created through Stable Diffusion. So this will actually get, this was what will pop up in a tweet card or in a Facebook post or on LinkedIn whenever anybody shares a link to this. And that's nice just from a visual branding perspective, but it just makes the overall experience a little better. If I hadn't done that, if I hadn't made those changes, this is the image that was configured in the template repository itself. So while it's nice and looks great, it's not specific to my actual project and app. And so I wanted to put in the effort to change the Open Graph stuff, partly to learn how it works, and then partly just to handle it for myself. So this is sort of the later piece where after I've set up that new route, the OG route, you can insert this new meta tag and say that the property OG image is at this content URL. So that's the exact URL I just showed you, where we've got the Open Graph image. So if a crawler or a website hits this, they'll get that image. And so that's how that works. These changes were for analytics. I was installing Vercel analytics so that I can just keep an eye on usage of the app overall. So this is the new route that I added. There's documentation for how to use this in Vercel, and honestly, this is one of the more finicky bits, I think, that I experienced in getting this app to work the way that I wanted it to. The documentation is great. It's pretty extensive, but in my case, there was a weird issue that resulted from wanting to use a local image and then also wanting to deviate a bit from the example. But in essence, this image response is a special type of response that you can use in order to fetch dynamic external images. So for example, a GitHub user profile image, or any other image, or maybe a GIF, I think in many cases, that is hosted externally. You can also use a local image, local to your actual Next.js project itself, in which case you need to load the image and then return this, array buffer. I decided to finally just host this Office Oracle OG image. So that's the little circular image at a static URL. And I did that by creating a new public directory in my Next.js app and adding just that one image that I wanted. And then you implement this get function, which normally takes a standard request, but I wasn't extracting any information from or modifying the request, so I decided just to drop it. And then once you set up this image here as a const, you await the image data itself, and then you need to pass that image data in to the circ source attribute of this image. This is where things got kind of funky, and I found this was the magical incantation to, because the type that's returned by or expected by this source attribute for the image itself is either string or undefined, and that will land you in trouble if you try and just return an array buffer, which is not a string itself. So in my case, I settled on first expanding image data to unknown and then a string. And that made TypeScript happy and also got the functionality that I wanted. In essence, though, when you use the Open Graph stuff on Vercel, what you're doing is creating an image response dynamically, if you wish, and you can style it, as you can see here. It can even be wrapped in a div, which makes it easier to use HTML and even Tailwind CSS if you wish. So the point is that you can make a really beautiful and even coherent with your brand Open Graph image through this interface. You can even specify width and height, and then you just return that image image response, and then that's what you get. These are all the images I generated with Stable Diffusion, just adding those, and then some slight modifications I needed to make to the index page. So this Oracle image is a component that I created here, and you'll notice that I'm actually calling it as a function inside of this, which is really the landing or splash page, which we're seeing over here. And so I did this because I wanted the functionality of if you refresh the page, you'll notice you get a different image every time. So it just makes it a little bit more dynamic overall. It's a pretty cheap fix to make things a little bit more visually interesting. There's I think 7 or 8 of the original Stable Diffusion images that I created. So that's what that does. That's how it's invoked, but down here a little bit, we'll see the actual component itself. I'm skipping a lot of the stuff because it's boilerplate that was also auto-generated from the Next.js framework itself. This audio stream is kind of interesting. This is where I'm creating. So again, if you want to go back and watch in the initial demo, I send in some text here, and I show that because I've integrated ElevenLabs, which is right here, they have this voice cloning functionality. So if you provide source images or video, source video or audio, anywhere from 1 to 5 minutes or less in some cases, you can get a pretty accurate voice clone. And so this is a just custom file that I wrote to essentially fetch the audio stream itself by sending in the text, right? So the user asks a query, the AI chatbot responds by first, as we talked about before, going to the vector store, getting contextual queries, getting contextually relevant source documents, returning them to the LLM. The LLM will then use those and consider those documents in answering the user's query. When the user's query is answered, that gets written back to the UI. And then what I decided to do just for this V1, and mostly for my own learning and curiosity, was to add a little button. So if you click the button, it's terrible UX, and it's not easy to see. If you click the button, then this audio stream function is run, essentially. And what we do is convert the text, which is the body of the content that was sent in, or that was produced by the LLM, right? So this is like post response. We make a request to the ElevenLabs API. We specify the voice ID, which is also set as an envar, even though it's not a secret. And then do a post, and then we get back URL, which is sufficient for creating or wrapping into an actual audio object that can be played, and then we just immediately play it. So the other, among the many UX issues there are with this one, is that you can only play it once. It's not super obvious. If you misheard it, you can't play it again. It doesn't make a nice little scrubber for you to see and then jump back and forth through responses. It doesn't nicely save that text or the text-to-speech essentially recording with the text itself. These are all future enhancements that I could make, but it was really just wanted to understand the quick and dirty approach to getting it working. So this is this custom audio stream, and it works sufficiently for sending in arbitrary text and getting it spoken in a custom voice that you've already created on ElevenLabs. So feel free to view and lift that code on GitHub. And then these are the simple modifications I needed to make in React in order to make that functionality work. So just creating this use state block, and then defining a function called speak Michael, which can be called by pressing this button, which is just a user button for now, for just the purposes of doing it quickly. Okie dokie. So I think the last thing I want to talk about really is this Office Oracle. So this is a little bit of extra content that I put on the homepage. So these are these sort of example headings to get you started with stuff, and if you click any of them, you get the prompt that was underneath it. So there's also an interesting bug, which I think is kind of cool, that every time I click one of these, it reloads the image, which is fine for now. But you can draft draft humorous email or whatever. These are all just set up as objects that have a heading and a message. So the heading is what is presented to the user here in the UI, and the message is what gets set in the prompt when you click it, and would get sent to the model if you were to hit enter. And then these are just modifications I needed to make in order to do the, style the app in my own way. And then I think down here I rewrote some of the links. I took out the Vercel specific stuff. Yep. And then this is the component that I wrote, which is very simple, that just randomly rotates through the known images that are already stored in the project locally. So it's a really just simple, usual JavaScript math.random trick to get whichever image and then just return that image. So that's how that works when it's iterating through multiple images. The only other thing I decided to add was just I found a lamp loading GIF and added that as a spinner. And so if I basically tapped into the already existing is loading Boolean in React, and so I can just, when the user sends a message, because we're doing quite a bit, right? Like we are going to a vector store database, which itself is super fast, but then we're also feeding that context back to an LLM and a separate API, waiting for that response. And in some cases that can be at least a couple seconds. So This really just shows this loading GIF in order to kind of signal to the user, hey, I haven't dropped you. This request is still processing, essentially. Yep, and then just some minor like animate ping on the enter button for the prompt just to make it a little bit more obvious. And then the rest after that starts to get into just more auto-generated stuff. So in essence, those are the main changes that I made. And if we now look back through, another way to just quickly get a sense of this is if we jump to my repo and go back through the commits. So I think this was like kind of nights and maybe one weekend for about a week and a half or so. And you can kind of look through here and see what the main features were done, because I tended to put those in the pull request if they were larger. So like here's the PR to add audio streaming capability or the text-to-speech ability. A future improvement for this would definitely be allowing users to enable or disable audio from the get. In the beginning of the app UX somewhere, they could turn that on or off. Maybe it defaults to off so it doesn't surprise anybody. And then to definitely store the recordings along with the text. I'm not storing anything now, but it would be a good excuse to try out Vercel storage functions or their KV stores or database, etc. And then I think it would also be nice to essentially, so the rest of this is diffs, but yeah, the changes themselves are pretty simple. It would also be nice to maybe immediately start playing or immediately hand off the text to ElevenLabs for processing as soon as the LLM returned the response, because in some cases that would allow just slightly better UX where the text-to-speech recording would be available kind of as the user is reading through. And so that might just make the overall app experience a little bit more responsive. It might feel like it's actually kind of talking to you. So that's one future enhancement I might consider. And then there was just a whole bunch of iteration where I needed to try out different prompts. You can see, like, as I was talking about before, there's one giant prompt I had that was really a smell because I was trying to work around like low data quality in my case, and then just tons of iteration on various langchain setups until I found what I really wanted, which was the VectorDB backed conversational QA retrieval chain. Yep, and then other than that, other than UI or branding fixes, for the most part, it was the recently it's been the Open Graph changes that I talked about, and just wrestling with TypeScript to get that working. So yeah, in essence, that is it. So to summarize, if you want to build your own AI chatbot, there's lots of good material on that now. In this video series, I kind of talked through the main points of how I did it myself, and I used this ElevenLabs AI chatbot template, which I found to be extremely useful. It had a lot of the features that I wanted already, and I just needed to disable and change the things that I didn't need or want for my particular use case, but overall, pretty good. Highly recommend it. All right, that's it for this video. Thanks so much for watching.